We have been working in our unit on quadratic graphs. We graphed quadratic functions that were in vertex form. Then we looked at quadratic functions that were in standard form, and we used the complete the square method to put them in vertex form. But then finally we learned a little bit of a shortcut for finding the vertex of a parabola without having to go through the complete the square process. Okay, and that was, we could do the opposite of b over 2 times a. That would give us the x, or the h value, and then we would substitute in that x into the function. We do f of that negative b over 2a to get the y. Okay, so this gives us a little bit, possibly a quicker way for finding the vertex. All right, so if we want to find the x, which is the h in vertex form, we're going to do the opposite of b over 2 times a. Okay, so for our example here, our b value is 6. Okay, so we're going to do the opposite of b is negative 6 over 2a. Our a is that understood 1 in the front. Okay, so that gives us negative 6 over 2. So the x, the ordered pair, is negative 3. Okay, and then we're going to just plug that into the original function. Negative 3 squared plus 6 times negative 3 plus 5. So 9 minus 18 plus 5. 9 minus 18 is negative 9 plus 5 is negative 4. Okay, all right, so the vertex of this parabola is negative 3, negative 4. Because the value of a is positive, that tells us that this parabola opens up, and therefore that vertex is in fact a minimum. Okay, so we're going to now use that information to fill in our statement. This graph has a minimum value of negative 4 when x equals negative 3. That's our min-max statement they're going to write at the end of each one. All right, let's try another example. Okay, so we're going to do negative b over 2a, and then f of negative b over 2a. All right, so the h, that will give us the x coordinate. Okay, all right, we want to do the opposite of b over 2 times a. All right, b this time is negative 8. Opposite of negative 8 is positive 8. 2a, our a is negative 2. 2 times negative 2 is negative 4. 8 divided by negative 4 is negative 2. So there's our x, and then we'll plug that in. F of negative 2 is negative 2 times negative 2 squared minus 8 times negative 2 minus 10. Okay, order of operations, negative 2 squared is 4 times negative 2 is negative 8. Minus 8 times negative 2 becomes plus 16 minus 10. Negative 8 plus 16 is 8. 8 minus 10 is negative 2. All right, now this time we have a lead coefficient, an a value that is negative. Anytime you have a negative lead coefficient, it'll open down. And so therefore the vertex of this parabola is a maximum. Okay? So we'll fill in our max-min statement. The graph has a maximum value of negative 2 when x equals negative 2. Okay, remember the value is the function value, the output, so that's y, and it happens when x equals negative 2. Okay, one more of these. All right, go a little quicker. All right, h is negative b over 2a. Okay, b is negative 4, so the opposite of negative 4 is positive 4. 2 times a, 2 times negative 1 is negative 2. 4 divided by negative 2 is negative 2. So we have negative 2 as the x coordinate, and then we'll plug that in. F of negative 2 is the negative of negative 2 squared minus 4 times negative 2 minus 8. Negative 2 squared is 4 times negative 1 is negative 4 plus 8 minus 8 So we have -4 as the y. Okay, again, we have a negative in the front, therefore it opens down. Therefore, this is a maximum. The vertex is a maximum. So our max-min statement will be this graph has a maximum value of -4 when x equals -2. All right, one example that is an application. Suppose a rocket is fired into the air such that its height in feet x seconds later is modeled by the function shown below. If this quadratic function is graphed, what would the vertex be? Is the vertex a maximum or minimum point, and what would this mean? All right, so let's find that vertex first. Okay, we'll do the opposite of b over 2a. Okay, b is 48, so the opposite of 48 is -48 over 2 times a. 2 times -16 is -32. Okay, -48 divided by -32, well, that's not going to come out as a whole number. Okay, we can use fractions, or for later, maybe possibly we might want to use decimals. So let's divide that out on our calculator. 48 divided by 32 is 1.5. Okay, all right, so there's the first part. Oops, sorry about that. Okay, the x-coordinate is 1.5. All right, now the y-coordinate, we want to do h of 1.5. So -16 times 1.5 squared plus 48 times 1.5 plus 20. Okay, all right, I'm going to go to my calculator for that. Squared multiplied by 16 negative plus 48 times 1.5 plus 20. Sorry, I'm having a little technical difficulty with my calculator. All right, assuming I entered that in the calculator correctly, I got 56. Okay, so this has a negative lead coefficient. Okay, so therefore this parabola opens down, and that is a maximum point. Okay, now instead of saying this has a maximum value, let's talk in terms of the rocket that was fired into the air. Okay, all right. If our input variable x was how many seconds had passed, so that means 1.5 seconds had passed. Okay, and the output, the h or y value, is 56. That's the height. Okay, so we could go a little further than our normal max-min statement and say that the maximum height is 56 feet when 1.5 seconds have passed. Okay, so that would be a good application of these maximum minimum problems.